2 will be on Compton effect.
The Compton effect. So the first thing that I would like to cover is a variation of mass with velocity. Now you know that even you did this in your class 12, the modern physics part, that basically mass, as you know, that till your class 12, even some part of it in your till now, you have considered mass wherever you took in your calculation, mass is constant. But according to Einstein in his relativistic theory, that mass in some cases does not remain constant. What is the case? The case is when a particular mass or a body moves close to the velocity of light, then the value of the mass does not remain constant, it changes by the formula m is equal to m0 root over 1 minus v square by c square. Now what is m0? m0 is the mass when the body or that mass is rest. That means it is stationary. And when this mass or body moves with a velocity close to light, say for example, velocity of light is 3 into 10 raised to 8 meter per second, and it is moving with say 2 into 10 raised to 7 meter per second. It's almost close to velocity of light. That time, if you substitute the velocity of the body v and then use this formula where c is the velocity of light, then after calculation m0 is the body rest mass body. That means when the body is at rest, that mass. Then you get the value of mass when it is moving with so the value of the mass is changing. Now you may ask me a question that, sir, if we are moving with some velocity, say 50 meter per second, or say 180 kilometer when we are riding a bike. So when we are riding a bike or when we are going say for example by a train, will our mass remain constant or it will change with the velocity? Now see, when you are talking about moving by train, moving by a bike, the velocity, that velocity is very, very less compared to velocity of light. So if you substitute this value v very, very less, actually that mass that you will calculate after putting the value, say velocity of you riding a bike or velocity of you going by train, then you will find that the mass, because v is very, very less than c, you will find that the mass, calculated mass and the rest mass is equal. But when mass changes in this condition when the velocity is comparable to velocity of light. Then if you substitute the value, the mass changes with the rest of mass. But if you substitute the value of v, some body moving with velocity greater or say for example equal to velocity of light, then according to this equation, the mass becomes infinite. So if you just think about say a planet or a star where the light is coming from and reaching our Earth, then immediately we can find out that that velocity or the mass of the particle, the source of originating, has a huge mass. So this is not it is an extraordinary case where v equal to c. Now we move to the next part, which is called this equation you already read in your modern physics in class 12, that what is the mass of a matter. So when you have a mass compact in a matter, in the form of a matter, the energy is given by E is equal to mc square, which is called the mass energy relation, and m is the mass, c is the velocity of light. Now we move to the next part. Suppose, so the first part, this slide talks about the momentum P. You know the definition of momentum. If I ask you what is momentum, you will tell me momentum is mass into velocity. But in this slide, actually the relation between momentum and energy is discussed. E is the energy, P is the momentum, M is the mass. And you know, so when I talk about a particle moving with the velocity of light and the mass changes, then that mass is called relativistic mass. And when a body whose mass remains constant, till now till now, whatever you have done in your calculation, right from your class 7, 8, 9, 10, 11, 12, you have kept the mass constant. Okay, you started from Newton's second law, first law, then conservation of energy, you have considered mass to remain constant. And for that case, when mass remains constant, we say it's a non-relativistic case. And when mass does not remain constant, we say relativistic mass. That means when does it happen? It happens when that body of mass m moves with a velocity v comparable to c. That time your mass changes. So if I ask you that when the mass remains constant, the case is called non-relativistic, and in that time, what is the relation between energy and momentum? We say E is equal to P square divided by 2m. Why? How is it done? You just write the value of P here. It is P is called the mass into velocity. It is square. So you write m square v square divided by 2m. You get half mv square. That is kinetic energy. This relation you have done it from class 7, then 9, then 11, many times. But now, if the body is relativistic mass, which means that the body is moving with close to velocity of light, that means mass is changing. In that case, the energy and the momentum relation is not this one. It is this one. E square is equal to m0 square c to the power of 4 plus p square c square. What is E? E is the energy. m0 is the rest mass when the mass is stationary or moving with some velocity which is not comparable with velocity of light. And p is the momentum and c is the velocity of light. So these two important discussion or the important points that is required to study Compton effect. Let me recap this two slides once again. The first point, that if you have a body moving with some velocity not comparable to light, then the mass remains constant and the energy and momentum relation is this one, which is called the non-relativistic mass. And if you have a body moving with a velocity of light, close to velocity of light, then the energy momentum is given by this formula. And what is the energy relation with mass? It is called E is equal to mc square, which we have discussed in the last slide. So this two important physics is very much important because we need this knowledge or concept to explain Compton effect. We move to the next slide, which we discussed there, where we discussed Compton effect. I hope that this slide is clear to you. Okay. Now, before I start with the Compton effect, this is a very, very important. Please listen to it very carefully. Now, before I start with the Compton effect, let me tell you, this part is also known to you. Let me tell you 1 second. If I have a photon, what is the energy of the photon? It is equal to, E is equal to h nu. And what is h? H is called the Planck's constant. Nu is the frequency. Now I can also write down this energy. Suppose if I consider a wave or a wave of light, or if I consider a photon of frequency nu, then we can say that the energy is equal to h nu of that photon. Because you already discussed in my last class that light behaves as a wave and light behaves as a particle, and that particle is called photon, depending upon the situation. In this case, we consider light as a photon or a particle, and the energy of the photon depends upon the frequency and it is equal to h into nu. Nu is the frequency of that photon. Now you can also write down this equation in terms of wavelength. How do I write? So what is the relation between frequency and wavelength? Nu, frequency, is equal to c, velocity of light, divided by wavelength, lambda. So if you substitute this value of nu here, then you get hc by lambda, which is the relation between energy and wavelength. So if you see this equation, E is directly proportional to frequency, which means that frequency increases, energy increases. And wavelength is inversely proportional to energy, that when you decrease wavelength, energy is more. Now what is Compton effect? Just listen to me very carefully. Suppose you have an incident light. Let us say that light, the particle is photon. So I can say incident photon. Let us say it is a blue light. To visualize yourself, imagine that this light is only blue light. So when you talk about only blue light, we say that this blue light will have a particular wavelength, let us say lambda. Now this blue light hits an electron. Electron is here, this dark portion, the dark one symbolizes electron. This blue light of having wavelength lambda, you can also express yourself not instead of lambda, you can also say a light of particular frequency. When I say blue light will have a particular wavelength. Similarly, blue light will have a particular frequency. Same thing. Either you can hold your nose in this way or another way. It's the same thing. Either you can explain this photon in terms of frequency or in terms of wavelength. So I will explain in terms of wavelength now. So if I have a blue light and wavelength lambda, this blue light hits an electron. The electron recoils. Recoils means chitke jawa, berin jawa, knocks the electron. And then after hitting the electron, we get another light, color of light, and I say it is lambda dash. And what is the color of light? Let us say it is red. Let us say just to visualize yourself. So what happens? You have a particular color of light hitting the electron recoils, chitke jai, and then the reflected or the scattered light is having a different color. Different color means different frequency or different wavelength. In this case, I am considering only wavelength. I'm not talking about frequency. So, and what is the relation between frequency and wavelength is given here. So obviously, your wavelength changes. How does it change? What is the physics or why does it change? Suppose, imagine yourself as a blue light. That means you have full blue color and you have an energy. What is your energy? For blue light, you have a wavelength. You substitute the value of wavelength. H and C is known to you. H and C is known to you. You get an energy. So blue light will have an energy. Hits the electron. Just imagine you are a blue light. You color yourself blue and you hit your friend. A friend of you are sitting in a bench. Okay. So once you hit your friend is say moves in some other direction and you also move in other direction. You are there, yes, like this scattered one. So what you have done, you have given some of your energy. Energy is calculated using this formula. You have given some of the energy to the electron after knocking. So some of the energy is already given. So now when you are scattering after hitting, when you are moving to the other direction, you have less energy, remember. So your energy is now less because you have given some of the energy to the electron. Now this energy is now reduced. Obviously your wavelength will increase because, so that is why your wavelength is changing and it is changing to blue to red. You understood? So you have a color of light, say blue, you hit the electron and then after electron is knocked down, you reflect or you scattered in some other direction and that time the color of your light changes, say blue to red. And why does it change to red? Why does it does not change to say ultraviolet? Because the energy when you hit the electron, some of the energy goes to the electron and the remaining energy, if you have that energy, you are going out. So that energy, that less energy, when you have less energy, your wavelength increases. So it becomes blue to red. Now, if you just take this diagram into consideration, the theta is the angle where the electron is recoiled. That means electron কোন angle যদি electron এইভাবে সোজাসুজি যেত, if it moves straight way, then this angle is 0. Which means that if the electron moves in this way, then taking this into reference line, this angle is called the theta. Theta is what? The scattered electron direction. মানে ইলেকট্রন যে ছিটকে গেছে তার ডিরেকশন হচ্ছে থিটা। আর ফোটন যে অ্যাঙ্গেলে ছিটকেছে, the scattered photon angle is denoted as phi. So we have a formula. This formula is very, very important. Now you may ask me, before I get into this formula, you may ask me, sir, how do you get this? So if you start with the wavelength lambda, or you can express in terms of frequency, nu is equal to c by lambda. So if your wavelength changes, obviously your frequency will change. So I write down nu dash equal to c by lambda dash. But throughout the chapter, I'm going to explain in terms of, I will hold my nose straight way, not in the other way. You can also express yourself in terms of frequency. You will get the same result. Because you have the relation between nu and wavelength. Now, So this is your lambda. It is called the incident wavelength. What is incident wavelength? the light which is before it hits, that means J wavelength ba J color of light ta niye electron ke dhakka marche. That is called the incident light. Tar wavelength lambda. And after knocking the electron, সেই color of সেই photon ta, or that photon will move with a particular wavelength. That wavelength is lambda dash. And what is the relation? Lambda dash, that means scattered photon wavelength, minus lambda incident photon wavelength, is equal to lambda c. This is constant, and the value of the constant is here, into 1 minus cos phi. And what is phi? Phi is the scattered photon. Now what is lambda c? Lambda c is called a constant which is called the Compton wavelength. The constant is named as Compton wavelength because Compton has done this. So this constant was named after him, and it is called the Compton wavelength. Lambda c, which is equal to h, Planck's constant, m0, the mass of an electron, and c, the velocity of an electron. Now if you ask me what is the mass of an electron, it is 9.1 10 raised to minus 31 kg. Now what is our, in my next slide, so in my next slide or in the coming slide, we are going to derive this relation, and this relation is very, very important in terms of derivation, in terms of numericals, because every time either they give this derivation in Wbut, or they give numericals, and you have to calculate the numericals based on this formula. And there are other formulas coming from this derivation. But what we are going to do now, we are going to do this derivation. So I request everyone, please take your pen, paper now, not calculator, because we'll do numericals later on. Because what I want to do, just write down what I'm saying yourself. Suppose if you miss, don't worry, because you have the entire thing in your notes. You can again go back. But if you write down yourself in front of you, it becomes very easy. Even whatever you write, it becomes logical, and you will get it very easily. So I request you, please take your pen, pencil, paper, and try to go with me, whatever I explain you. Now, before I get into this derivation, let me tell you, I told you in this thing that blue light hits the electron and gets scattered, right? But believe me, you cannot perform this experiment using any kind of visible light. That means you cannot use violet, indigo, blue, green, orange, red, and all this. You will not get the experiment. You will not get successful in this experiment. Why? Reason is that suppose you use violet, blue, green, yellow, orange, red, the visible part, this light or these wavelengths will not have the energy. So if you substitute the value of, say, if you substitute the value of blue, yellow, orange, red, and you perform the experiment different time, you will get energy for every wavelength, and you perform the experiment, but you will not get anything. The reason is that this energy which you calculate for any of the visible color of light will not hit the electron and recoil, because this energy is very, very less to knock out the electron. Suppose you imagine yourself very thin, and your friend who you want to knock is very fat or very healthy, and then what you do, you don't take your breakfast and you try to knock. You cannot knock because the energy yourself is very less. You cannot knock your friend. Something like this. The violet, indigo, blue, green, orange, red, their wavelength, if you substitute, the energy is less and you cannot knock. This is one of the reasons. So what we do, you can perform this experiment. You can perform this experiment by using lower wavelength. Say for example, gamma, X-ray, all these have lower wavelength. So when you have wavelength value very less, energy is very high, and this high energy can knock the electron, and then you can perform this experiment. So then you may ask me that, sir, why did you tell us about blue and red? Because if I don't ask you to visualize that wavelength is changing, you will not understand. That is why I have done it. But basically, it is actually, practically speaking, it is performed only with wavelength less value, because energy is high. So the explanation for this Compton effect cannot be observed. This is a very important question. Wbut asked this question in a short question form. Compton effect cannot be observed with visible light. This explanation or answer is there in your class notes. Instead of using X-ray, if you use light in the visible range, the del lambda, that means lambda dash minus lambda. The del lambda is called the lambda dash, the scattered wavelength minus the incident wavelength will not be perceptible. It is not feasible. It will not occur. In this case, the photon energy is so small, hc by lambda is so small that it is not even larger than the binding energy of the loosely bound electrons in the scatter. So the energy of the X-ray photon, that means if you take an X-ray wavelength, that photon is very few times greater than the visible light. That is why it can knock an electron and you get a Compton effect. That means you get a scattered wavelength. We move to the next slide. That means we move to the derivation, I believe. Yeah. Now, I will ask you to take your pen paper, okay? And I will explain you very slowly. This is the most important slide of the derivation. Once you have this, everything is simple mathematics like your class 8-9 mathematics, algebra. So let me once again brief. This is the incident photon or incident light. This is the electron. The incident light knocks the electron. Electron recoils. Electron chitke jaচ্ছে with an angle theta, and photon chitke jaচ্ছে. Photon scatters with an angle phi. So if I ask you what is the angle of photon, you will say phi. If I ask you what is the angle of electron, you will say theta. Right? And if there is nothing, then photon will straight move in this direction. Okay, now this part is very, very, very important. All the small e is for photon. E stands for energy. All the small e, sometimes in physics we say this e as epsilon. All the small e, I'm talking about photon. All the small p, that was small p gulo ekটু অন্যরকম লেখা, capital P অন্যরকম লেখা. All the small p's are denote for photon, which is actually momentum. So E stands for energy, small e stands for energy for photon, small p stands for momentum for photon. Now capital E stands for energy for electron and capital P stands for energy for, momentum for electron. So all the small values, small capital and small letters, the small letters denote for photon and capital letters denote for electron. E stands for basically energy and P stands for momentum. Now what we are going to do, just listen to me very carefully. You have an incident photon, right? What is the energy of the incident photon? Depending upon its wavelength or frequency, E is equal to h nu or E is equal to hc by lambda. I write down in terms of frequency. I write the incident photon is if it is a light, a particular photon, it will have a frequency, a particular frequency. That frequency is nu. Multiplied by h will give you h nu. And what is h nu? It is the energy of this photon which is actually try to hit the electron. এখন hit করেনি, it will hit. So it is incident photon. Right? Now this photon, after hitting the electron will recoil. After hitting the electron, this photon will go in this direction. That time, this energy is h nu. Before hitting, this energy is h nu. Some of the energy goes to the electron. So the rest energy will be given by h nu dash. It is not h nu. Why h nu dash? Because energy will decrease because some of the energy will be given by to electron and the rest energy will go out, and the rest energy I can equate that into h nu dash, which is some other frequency, not the incident frequency. এই যে এটা দিয়ে যে বের হচ্ছে সেটা কিন্তু অন্য ফ্রিকোয়েন্সি, কারণ এনার্জি কমে গেছে, নিউ ড্যাশ ফ্রিকোয়েন্সিটাও কমে যাবে। যেমন আমি আগের স্লাইডে বোঝালাম, the previously I explained you in terms of wavelength, I'm trying to explain in terms of frequency. The same thing, holding your nose from this side and that side. Now, I'm talking about the energy of electron now. That is why it is denoted as capital letter. So E1 means before hitting, when it is at rest. মানে photon hit করার আগে electron যে চুপ করে বসে আছে তার ভ্যালুটা, it is m0 c square. M is the mass of the electron. See, just now we have discussed that matter, what is the energy of the matter? mc square according to Einstein, so mc square. Now, after this electron is hit, what is the energy? It is given by root over capital P2 square C square plus M0 square C to the power 4. Sir, why did you write this? The reason is that if you just go back to the second slide when I was explaining you, there was a relation between energy and momentum for relativistic case. E square is equal to P square plus C square plus M0 square C to the power 4. I have taken this relation. It was E square is equal to P square C square. I wrote E root over this. Why? Because this electron, when it gets scattered, it moves with a very high velocity close to light. That is why we are using the energy momentum relation for a relativistic case. Now if I explain you what are these terms, E2 is the energy when the electron chitke jache, recoil. P2 is the momentum of the electron, C is the velocity of light, M is the mass of the electron, C is the velocity of light. Now, I will talk about now photon, momentum, about photon. That is why I denoted a small letter, right? P1 is the momentum. Now, if you ask me why did you write h nu by c, this we have discussed in statistical mechanics. If you just think P as the mass into velocity, just imagine that mass into velocity. Now, you know that E is equal to mc square. E is equal to mc square. So, your E is h nu. So, E is equal to h nu equal to mc square. Just write down immediately or think about yourself. E is equal to mc square is equal to h nu. Take one of the C, ওই যে বাদিকে যে mc square, তার মধ্যে একটা C নিচে নামিয়ে নাও. So you get mc is equal to h nu by c. Now what is mc? mc is mass into velocity of light, which is momentum. So instead of writing mc, I'm writing momentum, which is equal to h nu by c. And it is incident photon energy chilo h nu divided by c. It is the momentum of the incident photon. তার মানে এই যে ফোটনটা যেটা হিট করছে ইলেকট্রনকে, therefore the momentum is denoted as P1 and the value is h nu by c. Similarly, what is the value of the scattered photon, momentum value for the scattered photon? It is the energy divided by c, h nu by c. কি করে আসলো? E is equal to mc square is equal to h nu dash. ওখান থেকে একটা c নিচে নামিয়ে নাও, mc is equal to h nu dash by c. তাহলে mc is what? The momentum. So that is the scattered momentum of a photon, scattered photon momentum denoted as P2. Now, coming to electron, denoted as capital P. P stands for momentum. যেহেতু electron is at rest, because electron is at rest, it is not having any velocity. So the electron which is rest now, পরে তো ছিটকে যাবে, পরে it will be knocked down by photon. But electron, that time when it is at rest, it is momentum is 0, and when it is hit by a photon, it moves with some velocity. Obviously, the momentum will be P2. সেই P2 ভ্যালুটা আমি বের করিনি, সেই P2 ভ্যালুটা আমি রেখে দিয়েছি. I kept it as P2 itself. I did not write down any formula because P2 I will find out P2 from these values. So I kept it as P2. So if I ask you what is P2, it is the momentum of the electron, capital P2, when it is knocked by the photon. So this part is clear to you, I hope. Now, you read already in class 9 as well as in class 11, conservation of energy and conservation of momentum. I will use these two physics and try to derive two equations. Please take your pencil. Conservation of energy means before hitting, who are the bodies? Electron and photon. So I will calculate the energy of both these bodies before hitting, before they knock. That means you and your friend, I will calculate the energy before you hit each other. And then after hitting, what will be your energy? So before hitting, your total energy is equal to after knocking your total energy. That is why I have written small e1 plus capital E1. Small e1 and capital E1 is the energy of photon and energy of the electron respectively before hitting, equal to after hitting. E2 is the scattered photon. Scatter কখন করলো? After hitting. So the energy is E2 plus capital E2 the recoil electron মানে ছিটকে যাওয়া ইলেকট্রন, তার এনার্জি হচ্ছে E2। সেজন্য conservation of energy before heating equal to after heating, the energy is always constant or equal। তারপরে কি করলাম, what I did next, I substituted this value of small e1 and capital E1 here, as well as small e2 and capital E2 from these values. Just you substitute yourself. Okay, so you substitute yourself. Then what do, you take this term, the root term, total root term, to the left hand side and bring all this term to the right. Now what you do, when this term h nu turns to the right, you can take a common of h and it becomes nu, sorry, this becomes sorry, I'm extremely sorry, you take this term to the left and keep here. So if you take this to the left, you get h common, nu minus nu dot plus m0 c square, and this term is left behind. Abar bolchi, if you take this term to the left, এই টার্মটাকে যদি তুমি বাদিকে নিয়ে যাও, আবার h common now, you get this. So that you name it as equation 1. Next, conservation of momentum. The conservation of momentum, the same thing like energy. Two bodies, one body is photon, other body is electron, two particles, right? So these two particles, their momentum before they hit or before they knock, and their moment equal to their momentum after they hit or after they knock. তার মানে তারা ধাক্কা লাগার আগে তাদের momentum, দুজনে ধাক্কা লাগার পরে তাদের momentum. So P1 is the momentum for the photon before hitting, P2, P1, capital P1 is the momentum for the electron. Similarly, P2 and P2 after the knock or after the hit. So I substitute the value here. I don't substitute the value, I just write down as P1 because I'm going to do it later on. See, small P1, that value h nu by c, I don't write now. I keep it later on. I will substitute, but later on. P1. Capital P1 এর value 0, সেটা আমি substitute করলাম। তারপরে small p2 এর value আছে, h nu dash by c, সেটা substitute করিনি, করব। Last, capital P2, I told you, capital P2, আমি রেখে দেবো, I will keep it as capital P2. আমি সেটাই রাখছি। Because I'm going to calculate, what I'm going to do, let me tell you, এই যে এখান থেকে যে equation 1 থেকে I will first find out capital P2, and from here I will find out capital P2, and then, or rather, I will find out capital P2 square and capital P2 square, and then equate them, and then I get the relation. Simple. By using both the equations, conservation of energy and conservation of momentum. So এখানে কি করলাম, এই ভ্যালুটা বসালাম, P1 আর P2, capital P2 এর ভ্যালু রেখে দিলাম। তাহলে এবার যদি আমি this small P2, the momentum value for the scattered photon, if I take it to the left, I get P1 minus P2, because they are vector quantity, even the quantities like that. Because momentum is a vector quantity, so I denote it as a vector sign, and I take it there. So P1 minus P2 is equal to capital P2. That is equation 2. Please write down. Now, we have this conservation of energy equation already explained to you. What I have done, so this is the conservation of energy equation in the last slide I have already explained you. Now what I am doing, I square both sides of this equation 1. So if I square this both sides, this square root goes out because I'm squaring, and this one, the whole thing, the whole h nu minus nu dash bracket plus m0 c square, the whole thing is to the power 2, one is square. So you can take this as a, this as b, and you can say a plus b the whole square, and apply the formula a square plus 2ab plus b square. You apply that formula, you get the square of this term. Then you will find that some terms get cancelled from here, and then after cancelling the terms, rearranging, that what is rearranging, keep p2 square to the left আর সবাইকে ডান দিকে নিয়ে যাও, p2 square কে বাদিকে রেখে এখান থেকে এই ইকুয়েশনটা থেকে স্কোয়ার করো, স্কোয়ার করে কাটাকাটি যা কিছু some terms will get cancelled and then you keep only the p2 term, p2 square to the left and the rest all the terms to the right, and name this equation 3. Okay, now I have already explained you p2, which is equal to small p1 minus p2. What I'm going to do, I'm going to basically take the dot product or square both sides. Now if I square both sides, I can write down p2 into p2, small p1 minus p1 dot or into p1 minus p2. Because they are vector quantity, if I take dot product, I can write p2 into p2 cos theta. Now what is the angle between two p2s? They are same, so angle is 0, so cos 0 1, so I can write p2 square. Similarly, if I multiply small p1 with small p1, what I'm going to get? p1 into p1, because I'm doing dot product, p1 into p1 cos 0. So what is the angle between p1 and p1? It is 0, so cos 0 1, so I'm writing p1 square. Next, p1 into p2. So p1 into p2 means minus p1 p2. What is the angle between p1 and p2? What is the angle between p1 and p2? Theta. p1 is this angle, p2 is this angle, so that's theta. Sorry, phi. This is p1, this is p2, the angle is phi. Because what is p1? p1 is this angle, this vector, which is moving in this direction. And p2 is the vector momentum for the scattered photon, this direction. So what is the angle between them? It is phi. So I'm writing p1 into p2 cos phi. So I have two such terms. আবার দেখো p1 p2 আসছে তো, আবার p2 p1 মাল্টিপ্লাই হবে, সেজন্য আমি লিখছি minus 2 p1 p2 cos phi. Similarly, p2 into p2 will give you p2 into p2, that means p2 cos 0, because what is the angle between p2 p2? It is 0, so cos 0 1, so I get p2 square. So if I square both sides, if I square this both sides, because it is a vector quantity, I can do dot product and I get this value. Now if I get this value, and if you understood correctly, now I'm going to substitute the value from here. So what is the value of p1? H nu by c. It is p1 square, so I write h nu by c whole square. What is the value of p2? It is h nu dash by c. I write h nu dash by c whole square. Similarly, p1 p2 I substitute here and I get this. I told you capital P2, the momentum for the recoil electron, I will keep it as p2 only. Now from this equation, I already have this. From this equation, how I have done, again I am repeating. I will square both sides and then I make p2 to the left, p2 square to the left, and all the term to the right. ঠিক সেইভাবে conservation of momentum থেকে আমি এটা পেলাম, I got this. I name this equation equation 3, I name this equation equation 4. এবার কি করব আমি, I will equate equation 3 and equation 4. দেখো equation 3 এর left hand side এ capital P2 square আছে, and equation 4 এর left hand side ও capital P2 square আছে. So if you equate the right hand side, and then you get the relation. So we are actually moving to that relation slowly. Yes. Yeah. So you have P2 from the conservation of energy after squaring and adding, rearranging, and you have from the momentum, you have the P2 term after substituting the value of P1, P2 from here. Before I did the squaring like the vector dot product. I have done the squaring of product by using the vector dot product. And I told you that P1 into P1, it becomes P1 square cos 0, because what is the angle between P1? It is, the angle is 0. Obviously, the same vector quantity, what will be the angle? It's 0. So after substituting the value, you get equation 4. Equate them, So before I equate them, equating 3 and 4, I have this. 3 right hand side, if you are holding a pen and paper, you just write down this equation 3, write down this equation 4, and you equate them. And equation 3 or equation 4 ki equal kor. তাহলে তোমার বাদিক আর ডান দিকটা equal, তাহলে you can equate basically. You can write 8 square, this term plus this term is equal to, sorry, this term. এই দুটো this equal to this, 3 equal to 4, straight way. করার পরে there will be some cancellation. After doing this, you have this relation. After equating, you will find some terms getting cancelled and you will have this equation. Now, after equating and doing some calculation, I have missed this step. It is your duty to do it. It is very, very important. I have missed that step because I'm not doing in the class. Obviously, I agree with you that the classroom teaching and the online teaching, there will be some problem with some technical issues and all. But it is your task. After equating this, you get this relation, equation 5. That's it. Once you get equation 5, actually you reach the derivation. I will show you. See, this is the equation 5. This is the equation 5 after equating 3 and 4. Right? So what I'm doing? What I do, I know that frequency is c by lambda, velocity of light by wavelength. And the scattered frequency is c by lambda dash. This is the scattered wavelength. So I told you in my initially that basically scattered frequency and wavelength are basically they are in the same. You are holding your nose in one of the way. Either you can tell the story in terms of frequency or you can tell the story in terms of wavelength. They mean the same. Now I want to convert this frequency into wavelength. Basically, I'm not doing anything. I have reached the derivation. I want to just convert the new frequency into wavelength. So what I'm doing, I have substituted this. First, what I have done, I have taken very important m0c by h. I have taken this side. So যদি এখানে এইদিকে আনি তাহলে h by m0c এখানে চলে আসবে এই যে গোটা টার্মটা, this one, mu dash by c square. Again, mu dash by c square. এটাকে ওদিকে পাঠালে কি হবে? এটাকে যদি ওদিকে পাঠাই, I will get c square by mu dash. আর এটাকে যদি এদিকে পাঠাই, I will get h by m0c. এবার তাহলে এদিকে বাদিকে এটা চলে আসছে এদিকে, এটা ওদিকে গেছে। This term ওদিকে গেলে কি হবে? এটা যদি ওদিকে যায়, এটা হবে c square by mu dash. এবার আমি ভাঙছি, এবার আমি ব্র্যাকেটটা খুলছি, গুণ করছি, I will multiply. So what I will have? c square by mu dash. এই c square এর সাথে এই mu dash এর গুণ হলে কি পাবো? I will get mu dash. I will get c by lambda dash. I repeat, you get c square উপরে, নিচে mu dash. তাহলে mu dash আর এখানে mu dash এর mu আর muটা কেটে যাবে, তাহলে নিচে থাকবে mu dash আর উপরে থাকবে একটা c, কারণ আছে c square. তাহলে c by mu dash is basically lambda dash. তেমনি আবার যখন এটার সাথে গুণ হবে, you will get c by lambda, you get basically c by mu, you get basically lambda. So এইটাকে যখন এটার সাথে নিয়ে এসে গুণ করবে, you are basically using this definition, you will get lambda dash minus lambda. And this h by m0c, this is the whole thing is a constant. I write down as lambda c and I get this relation. Lambda dash minus lambda is equal to lambda c, bracket open, 1 minus cos phi. So what is lambda dash? It is the scattered wavelength of the scattered photon. What is lambda? It is called the wavelength of the incident photon. And what is lambda? It is constant wavelength. It will remain constant everywhere. So what is phi? It is the angle at which the photon has scattered. কোন angle photon ছিটকে গেছে or get scattered. So from here you can sometimes this lambda dash minus lambda is called the change in Compton wavelength or you can say, change in Compton shift, or sometimes they say Compton shift. Again I repeat, lambda dash minus lambda, তার মানে যেই ওয়েভলেন্থটা নিয়ে ফোটন হিট করছে আর হিট করার পরে যে ওয়েভলেন্থটা নিয়ে স্ক্যাটার করলো তাদের বিয়োগ, that the difference is called Compton shift. Okay. Now I hope you have your question bank with you. If you don't have, no problem, we actually will start with the numerical. That is question number 6, very simple numerical. Let me explain you once again the diagram, and then I will move to the problem. You must be ready with your pen and pencil and calculator if required. I don't think so calculator is required, but still. So what do you have? You have an incident photon. So what is the numerical? What is the ratio of Compton shift? Compton shift মানে হচ্ছে lambda dash minus lambda, এই ভ্যালুটা, এই যে lambda dash minus lambda. Sometimes it is called, the difference it is called del lambda, এই যে del lambda. The formula is lambda c 1 minus cos. So what is the ratio of Compton shift for scattering at 0 degree and 90 degree? And calculate the Compton wavelength. This is the two different numerical. So first I will calculate the Compton wavelength. What is Compton wavelength? Compton wavelength is called, just now I told you in the derivation, lambda c, which is the value is h m0c. So what is the Compton lambda? H, the value of H is 6.6 to 10 raised to minus 34 joule second. M0, the mass of the electron 9.1 10 raised to minus 31. And C, the velocity of light 3 into 10 raised to 8 meter per second. If you substitute these values, you get del lambda, lambda C value is 0.0245, 10 raised to minus 10 meter. And 10 raised to minus 10 meter is written as Armstrong with the symbol A এর উপর একটা পুটকি. So এই যে ভ্যালুটা, এই যে lambda c এর ভ্যালুটা is basically this. Okay, so what is the value of Compton wavelength? Calculate. Simple. You just substitute the values of constant, all these constant, you get the value as 0.0245 into 10 raised to minus 10 meter. 10 raised to minus 10 meter কে আমরা ছোট করে লিখি Armstrong. So I write 0.0245 Armstrong. Now, the first part. What is the ratio of Compton shift? Ratio of Compton shift for scattering 0 and 90. তাহলে scattering 0 মানে photon is scattered. What is the angle? একবার আমি phi-টাকে 0 degree নেব, একবার phi-টাকে 90 degree নেব, আর দুটো বেলাতেই for both the cases I am going to calculate lambda dash minus lambda, which is called as del lambda, Compton shift. তাহলে 0 ডিগ্রির জন্য del lambda ক্যালকুলেট করব, আর 90 ডিগ্রির জন্য del lambda ক্যালকুলেট করব, এবং তাদের মধ্যে রেশিও নিয়ে নেব। del lambda ক্যালকুলেট করব for phi equal to 90 ডিগ্রি। তাহলে কত, জাস্ট phi cos 90 কত? cos 01 cos 90 0, তাহলে এখানে হয়ে যাবে 0, তাহলে হয়ে গেল del lambda is equal to h by m0c, h by m0c এইমাত্র ভ্যালু বার করলাম 0.0245 Armstrong। তাহলে Compton shift for phi equal to 90 degree, the value is this. And what is the Compton shift for phi is equal to 0 degree? এখানে cos 01 বসাবো, 1 minus 1 0 হয়ে যাবে, তাহলে গোটাটাই 0 হয়ে যাবে ডান দিকে, the right hand side the entire thing becomes 0. So del lambda is 0. For which angle? For 0 degree. What is the ratio? I take the ratio and I get this. So that is the solution for this numerical. একবার এসেছিল Wbut এই question. Next we move to the next one. Now, before I get into this problem, let me tell you that, one moment please. Yeah. Again, I explain you the once again the diagram. If you have the incident photon, a particular frequency of light or particular wavelength of light hits an electron, the electron recoils, ছিটকে যায়, and photon scatters. The angle of the photon is phi, let us say, and the angle of the electron at which the electron recoils is theta. But there is a calculation. That calculation I'm not doing now. It is there in the notes after that formula lambda dash minus lambda is equal to lambda c1 minus cos phi. It is there in the notes. I have taken the formula because a formula ta diye beshi onko ashe. So what is the relation between theta and phi? What is theta? Theta is the angle of the scattered electron. Please note, angle of the recoil electron. And phi is the angle of the scattered photon. তাদের মধ্যে রিলেশন হচ্ছে cot theta is equal to 1 plus alpha tan phi by 2. এটা ডেরিভেশনের থেকেও more important is the numerical. What is alpha? Alpha is again a constant. What is it? Alpha is equal to, not a constant, it depends upon frequency. Alpha is equal to h nu by m0 c square. Nu is the incident photon, the frequency of the incident photon. So it is h nu by m0 c square. Similarly, this is the kinetic energy of the photon, Ek. So this is the formula. It is also there in the note how to do the derivation, but this two formula more important in terms of numericals. You have to learn this formula to do the numericals. Derivation থেকে অঙ্কগুলো আসে, সেই জন্য অঙ্কটা করছি. Derivation is there in the notes. It is the, if you understood Compton effect, lambda dash minus lambda is equal to this, then you will understand this without doubt, I can tell you. But still, if you have any problem with, if you are interested in doing the derivation, then please do it, follow the notes, do it, and then again you come back to me. But more importantly, the numericals and the questions that Wbut asks. Wbut asks derivations, ask for derivation, but they ask the numericals more. Now we go to this numerical. Basically, this numerical will be solved by using this formula. Cot theta is equal to 1 plus alpha tan phi by 2. Alpha is this value. What is theta? Theta is the angle of the electron and the phi is the angle of the photon. A free electron at rest, the electron at rest, is struck by a X-ray. At an X-ray wave eshe ache ebong sei X-ray frequency is 5 into 10 raised to 9 hertz. If you ask me, sir, how do I convert this frequency of X-ray into wavelength? Simple. Nu frequency is equal to c by wavelength. You will see the velocity of light divided by wavelength. So you have frequency. You can calculate the wavelength of frequency by using the formula. Nu frequency is equal to c by wavelength. The photon is scattered at an angle of 90 degree. এই যে photon, এই যে phi টা সেটা বলে দিয়েছে 90 degree. Find the direction in which the electron will move. Electron কোন অ্যাঙ্গেলে যাবে, মুভ করবে, তার মানে থিটাটা বার করতে বলছে. You have to calculate theta. So phi is given, frequency is given, frequency of the incident photon or incident light. You have to calculate the theta. So you need this formula. Simple. So first, how will you do it? Please come back here. Those who are, please hold your pen, paper. Follow this. This is question bank numerical number 10. I'm using this formula cot theta is equal to 1 plus alpha tan phi by 2. First, I will calculate alpha. What is alpha? H nu by m0 c square. H Planck's constant, m0 mass of electron, c is the velocity of light, nu is the frequency of the incident photon. So I write down in this way. Please check. H mc. এখানে m0 c and m is the same. এই যে এইটাকে কায়দা করে hmc লিখেছি, কারণ this is basically Compton wavelength. H by mc is Compton wavelength, which I already know the value. And then I'm left with nu by c. What is nu? It is this one. সেটা লিখলাম. And what is c? Velocity of light. লিখলাম. লিখে alpha is 0.4. If you use your calculator, you can find out. So you have alpha now. This alpha is now known. Now what is your phi? Phi is 90 degree. So tan 90 by 2, tan 45. Use your calculator. 1, and you get this. So what I have done, you can use cot theta is equal to this value, then theta is equal to cot inverse এইভাবে করতে পারো. আমি কি করেছি, এটাকে উল্টে দিয়েছি. cot theta কে tan theta লিখে 1 by 1 by 1, কারণ এটা হচ্ছে 1, এটা হচ্ছে 1.4, তাহলে 1/1.4 মানে উল্টে দিয়েছি, cot theta কে tan theta করে 1/1.4 করেছি, তার ভ্যালু 0.74, তাহলে theta is equal to tan inverse 0.74, you get this 35.53 degree. So that's your theta or angle of the recoil electron. I hope you understood this. This is very simple, but this kind of numericals they go for it. But slowly we will go a bit, one or two a bit tougher, that we will discuss itself today from Compton. Next we move to question number, numerical number 11 from your question bank. What is Compton shift, if anyone asks you? Compton shift is what? It is the difference between the scattered wavelength and the incident wavelength. Lambda dash minus lambda is called Compton shift. Simple definition. Now with this there is a numerical. Find the change in wavelength, again the difference they are asking for it. They are asking for the, find the change in the wavelength. Basically they are asking for Compton shift. So lambda dash minus lambda, they are asking you to calculate. When it is scattered through an angle of 135 degree by a free electron. Okay. So the photon, the scattered angle of photon phi is 145 degree. So if you substitute in this formula h by m0c, already I showed you how to calculate this. This lambda c or h by m0c, they are same. It is called Compton wavelength. If you substitute the value of these values, you get this value and you write down in Armstrong 0.02426. Substitute all these values, you get 0.041 Armstrong. Please note that in the question bank, this or the notes, there is some calculation mistake, so I have recorrected this. This is the actual value. We move to the next problem. This is a very important problem, very important problem. Question number 12. Wbut te প্রচুর বার দিয়েছিল, অন্তত 3 বার from my knowledge. Question number 12, what does it say? It says prove that the maximum recoil energy of free electron rest mass, ওখানে যখন বসে আছে ওর mass is m0, when struck by a photon of wavelength lambda is given by this. This is the proof. Now, simple. I will use this formula basically. But before I use this formula, please note this signs very carefully. Listen to me very carefully. Suppose you have a photon of frequency nu, or you can say a photon of wavelength lambda, whatever you suggest or you consider, up to you. So you have a frequency of photon incident moving to the electron, hitting it, electron hits, recoils, and photon scatters. So if the frequency is nu, the energy is h nu, and after hitting, some of the energy it is going to give to the electron. So what is the amount of energy it is going to give to the electron? It is the difference between the incident energy and the scattered energy. So h nu minus h nu dash. So if you want to write down this whole thing in terms of wavelength, you can write down this. By the definition, nu is equal to c by lambda. See? Same thing. I'm writing this in terms of frequency, I'm writing this in terms of wavelength. But most importantly, if I ask you what is the energy given to the electron, I will say I am having some energy h nu as a photon. I will run and hit another electron and I will move out. So the move out energy and the energy before hitting I will subtract, and that energy is basically given to the electron. So that value is the energy given to the electron is h nu minus h nu dash. Right? Now, which condition or what is the value of maximum energy given to the electron? Now the question is, at which condition? Please very carefully listen. At which condition you will give the maximum energy to the electron? At which condition? The condition, it will be this fashion. You will give the maximum energy to the electron when your lambda dash, that means scattered photon wavelength, will be maximum. Why, sir? Because if you just see that when your lambda dash is less, maximum, the energy scattered, photon energy, will be minimum. যদি এটা maximum হয়, lambda dash scattered, lambda dash মানে হচ্ছে scattered photon wavelength. এটা যদি বেশি হয়, if this becomes maximum, then obviously hc by lambda dash, the whole thing, hc by lambda dash, this is the what? It is the energy of the scattered photon. That becomes minimum because you will find that lambda dash is in the denominator. Because it is in the denominator, hc by lambda dash is maximum, matlab hc by lambda dash becomes minimum. If this is minimum, when you are subtracting this as minimum, obviously your Emax will be some maximum. Suppose you have an energy, say 100, and your scattered energy is 2. Then the 98 joule you are giving to the electron. Now if your scattered energy is 50, then you subtract from your 100, your 50 is the energy given to the electron. So the scattered energy should be less. The scattered photon energy should be less. And how to make the scattered photon energy less? If the scattered photon wavelength is maximum. And how can I make the scattered photon wavelength maximum? If I take, this is the most important part, if I take the scattering angle phi to be pi, 180 degree, then only I will get lambda dash max as the maximum, So when you get phi is equal to pi, you get the scattered photon wavelength as maximum, and the value is 2 lambda c. What is lambda c? Compton wavelength. The value is here, plus lambda. So you substitute this value in this equation. এটা বসাও, দেখো এখানে বসিয়েছি, এই ভ্যালুটা এইখানটা বসিয়েছি, বসিয়ে এটা পাচ্ছি, which is simple. এটাকে যদি তুমি, if you do the LCM, you get this value, and then you have in the numerator you have HCm0 like this. So H টাকে replace করো by this m0 c lambda. If you ask me, sir, how did you replace this? I replace this using this formula. You write this, you get Emax equal to this. So simple. Once again, this is a very important problem. You want to give the maximum energy to the electron. How to give the maximum energy to the electron? Your scattered photon should have less energy. And how to have the scattered photon less energy? When your wavelength, because energy and wavelength, they are inversely proportional. So your wavelength of the scattered photon should be maximum. And to make the maximum wavelength of the scattered photon, the only condition left is phi is equal to pi. If you can change, if you don't believe me, you change the value of pi with different value angle, you will find the maximum value of lambda happens to be at phi equal to pi. And you get the relation E is equal to this. The last problem, and then we close up with some little conclusion discussion, and then we close up. Problem number 7 from Compton effect. This is a very easy problem. The last one I make it easy to make it interesting. A photon of frequency nu is scattered through an angle 90 degree in Compton scattering. Show that the scattered frequency by the photon is nu dash is given by this formula. So you again have this diagram in front of you. So this is the incident photon. The incident photon frequency is nu, given to you. And this is the scattered photon, whose frequency is nu dash, and you have to get this formula. And what is the angle phi? It is 90 degree. So you have this formula already derived. Lambda dash minus lambda is equal to lambda c 1 minus cos phi. Simply change this formula Simply change the value of lambda dash and lambda in terms of frequency. Nu and nu dash. So you can write down for lambda dash, you can write down C by nu dash, and for lambda you can write down C by nu. And substitute the value of Compton wavelength, which we say lambda C, as H by M0C. So there are two ways. This is bit, no use of writing this into two signs. You can write, this is also correct, but I would tell you that just substitute the value of cos phi. Phi is 90 degree. What is 90 degree? Cos 90 degree? 0. So you'll get lambda dash minus lambda is equal to lambda C. Then change the value of nu dash and lambda dash in place of this. তোমাকে sin square phi by 2 is a 2 sin theta formula in trigonometry. You don't have to change. You can change. And then substitute the value of pi and do the calculation in this way. But straight way also you can do it. Simple. You don't have to change it to 2 sin square theta. 2 sin square phi by 2 you don't have to change. Simple. Substitute the value of phi 90 degree here. Cos 90, 0. So this becomes 0. So you're left with the formula lambda dash minus lambda is equal to lambda C. এবার কি করো? Next, lambda dash change it to C by nu dash. And lambda change it to C by nu. Is equal to H by M0. এই lambda C টাকে এদিকে নিয়ে যাও. 1 minus cos phi, phi টা তো 0, cos phi টা 0 হয়ে গেল। তাহলে you are left with H by M0C. তারপর কি করবে? এই যে এটা এসে যাবে। তারপর তুমি এই এটা আসবে। এখান থেকে তুমি 1 by nu dash টাকে বাদিকে রাখবে, 1 by nu টা take it to the right. I hope you are getting it, those who are practicing. So you have 1 by nu dash, 1 by nu. Change this to the change 1 by nu to the right, and then you take the LCM of these two, and you get this, and then do the reverse reciprocal. So 1 by nu dash you get nu dash, and in each this denominator becomes the numerator, and you get the proof. That's the last part.
We come to the end of lecture 2, Compton effect. In lecture 3, we'll study de Broglie's hypothesis, and thank you again for your attention.